Thanks for coming out. We're going to do something a bit different. We're going to do a bit more experimenting. The session is called How to Expand Your Azure Stack Marketplace. I got probably a 2-minute session on the Azure Stack Marketplace. All of it is not necessarily to Azure Stack specifically. We're probably going to call it How to Experiment with Azure Artifacts. I think that's probably the best way. So my name is Mark van Eyck. I'm a program manager in Azure Cat. Azure Cat's a team within engineering that interacts with customers such as yourself and relays that into feedback so you get the products that we actually not only create but also align with what you need. I'm joined by...
Hey everyone, my name is Heath Lawson. I'm a content developer at Microsoft, so me and the team that I'm on drive most of the documentation and artifacts like that that you see around Azure Stack in particular.
And later on we'll have Carsten Rockfall, which is a customer from Germany. I think he's still doing a theater session right now. Oh, he's walking in right now. So he'll do the actual Azure Stack presentation based on the experience that he had with Azure Stack. So what are the key takeaways for this session? First of all, it's about DevOps. Probably the title cut you off guard. The content has been created after I crafted the title and submitted it, so it might be a bit different. I'll try to at least stick with it. We'll go through some terminology. Who's familiar with DevOps? Perfect. I was hoping for this audience. Hopefully we can get through certain slides. I think I have 12 pretty quick. If not, I'll stop wherever. The rest of it is all demos. I've been working on a test suite for ARM-related artifacts. And that's a whole bunch of different type of artifacts that you can think of, not necessarily for Azure Stack alone, but also for Azure. So it could be ARM templates, could be managed apps, could be complete marketplace items for Azure or marketplace items for Azure Stack for that matter. And we're going to look at lifecycle management for those artifacts. While we are still starting, I thought it was a good idea to pull this slide up now because I always forget it. And I get poor scoring because no one actually scores. So I'm just going to pull it up now. Evaluate the session because it helps us to not only do a session next year, but also get some cycles to spend on the content, which is valuable for you because you can use that in your own environment. There's 2 items that might be interesting. If you pass the, I think it's called the hide in the middle, there's an emergence zone where you can get some hands-on labs as well as the training that we're doing as Azure Cat. They're free, so feel free to walk by and take those tests. I'm going to hand it over to Heath. He's going to give you an overview of what the DAS world, what a day-to-day in the life of a dev kind of looks like. And then after that, I'll try to relate that back to how is that useful for ARM, and how is that useful for related artifacts, and can we use the same tooling, and how can we integrate the two together. So Heath, take it away.
Yeah, thanks Mark. So we're going to start off by talking just a little bit around one of the common scenarios that we hear out of customers when we start talking around Azure and Azure Stack together. And I really want to use this as an opportunity just to kind of set the stage, bring everyone to the same level when we start using some of the terms you'll hear in Mark's portion of the session there. This is just kind of an opportunity to look at like a CI/CD pipeline, tear it apart just a little bit over 10 or 12 minutes, set that kind of baseline for everybody, and then we'll move on from there. So we'll start with that. So let me cut over here real quick. Hopefully everyone can see my screen. So a common scenario we hear out of customers and we hear is that, hey, I want to use Azure Stack for my dev test kind of QA environments, Azure for my dev test QA environments, and I want to use Azure Stack for my production environments. And so this is a great opportunity for us just to show off a CI/CD pipeline. I'm going to be using Visual Studio Online to do that. It's going to be just a simple .NET app. Again, the key piece here is not focusing on the code that we're pushing, but rather just some of the terminology that you're going to hear out of it. So with that, let's get started. So I've got a basic web app. And if we go take a peek real quick, we'll actually see back here, it's just a sample ASP.NET app. Nothing fancy. I'm not a dev at heart. I'm just good enough to get some words on the screen, all right? So if we start with this, we go take a piece right here, we can see this is where we want to make some changes. So let's personalize this app for Ignite. And we're just going to tweak that to say, hello, Ignite 2017. And we're going to change our little line down there to say something to that. This is an application delivered to Azure and Azure Stack with VSO. Cool. So some things are going to happen as soon as I click Save, all right? And you might hear some terminology around this. I'm going to save this. So we're going to see some stuff happen here in Visual Studio Code. Notice right there, I immediately had a box pop up. Folks aren't using VS Code. It's a phenomenal platform. It's great for pretty much any type of editing you can think of. PowerShell, JSON, actually doing .NET development, Node, you name it, it's all here. What I love about it, and I spend a lot of time in VS Code each day, is it's got built-in source control. So from here, what I'm able to do is I can see my change, right? And if I click on this change, one of the beauties of using source control is it tells me exactly where those changes are, what I've changed, and I'm keeping track of this. So kind of think of it as a database of changes that have happened to your source or maybe PowerShell scripts or whatever the case may be. You can start getting some really good data back out of that on what changed, hey, it worked in this version, didn't work in that version. You can pull that back out. So here, this looks good to me. So I'm going to stage this change. So I'm going to click this little plus sign here. And that's cool. I've kind of checked in that change. The next thing that I'm going to do is I'm going to go ahead and commit. And a commit in kind of source control terminology means that I'm going to commit that change and just kind of lock it in as a change that I want to stage on up the pipe. So I'm going to click commit. And you'll see it's going to ask me for a commit message. So we're going to say this. We're going to say we're going to personalize this to Ignite. And we're going to hit enter. So that's cool. Keep in mind I'm working on my local copy of these files, my local repo, my local clone of this repo sitting up. So now we need to push this up online to Visual Studio Online. So we're going to click push. And the moment that this finishes up, we're actually going to set in place a whole series of orchestration pieces that are pretty straightforward, but there's a lot of gears that are starting to turn now just based upon this single push of changes. So if we go out and take a peek, here in just a little bit we're going to see this change. We can actually watch and see. We should see a build fire up here. We'll go dig in on our builds and take a look. I'll spend a little bit of time drilling in on this. We can see that I have a build in progress. What's actually happening is we're taking that ASP.NET code, we're running MS Build against it, compiling it, turning it into a web application that then we can subsequently, once this is done, release out to our servers. I'll show you some of the magic along the way. So we'll give this just a moment. And the first step that we've done here, just to kind of tee this up while we wait here, while we're releasing to Azure, we've actually set a stage in there where we have to go in and approve our release to Azure Stack. We've said, hey, you know what? I want to deploy to Azure, maybe go take a peek at it, and then I want to go approve it and release it to Azure Stack. So we'll see that. So we can see our build succeeded. If we go take a peek, we can now see our releases in the chute. It's headed towards Azure. We can tell that by this nice little blue box here. So if we drill in, we can watch and see, hey, I'm actually pushing to Azure, my Azure dev environment in progress. We'll give this just a little bit longer here, maybe within the next minute or so. Should wrap up. And then as soon as this finishes, we'll go take a look at our website. And we'll see those changes we made pushed up to an app service in Azure. Shouldn't be too much longer. The wait during demos and in front of audiences like this is always the best part. Moment of suspense. And we should see it turn green.
You're on the Wi-Fi, aren't you?
Yeah. It'll turn. I have the faith. And I'm getting emails now saying that, hey, my build is complete, my notifications are complete. There we go. Great, we've got our green check mark. So now if we come out here, we click refresh. Here is our old version. You can see it's run on AzureWebsites.net. I know that I'm pushing to my Azure instance of an app service website. This will take us just a few seconds to warm up those new pages we just pushed. If we were doing this in production, we'd use app service slots, and we'd rotate the slots, and we can kind of warm them up ahead of time. For the sake of this, yay, we've got our code pushed. So I don't know about you guys, but this looks good to me. I've pushed out the changes that I want. They're sitting out in my test environment. I may run additional tests through this pipeline, but for the sake of this, looks good to me. So now I'm going to go out and approve this. And what's really cool about this is, I don't know about y'all, but I know in the past, especially when we think around just this pipeline and the capabilities that this brings to the table, things like workflow and approvals. We used to do that with tools in the past that they took a lot of customization, a lot of effort. I'll show you guys where this is at. You can turn this on with a checkbox, basically. So pretty powerful. So we're going to approve it. And if we pop out here, we'll see it's actually going to kick off to Azure Stack. I've got an Azure Stack instance here we're going to go check on in just a moment. We can see my build is my deployment is in progress. We'll give this another minute. This one's usually a little quicker. Once this turns green, we'll go take a look at that site. We'll see, hey, we've released to our production environment. We feel good with those changes. And then we'll go take a peek at what all happened behind the scenes. There we go. We've got our green box. Everything's good. We've hit both our deployments are green. So now we're going to pop over. We're going to refresh on Azure Stack. This is the same Azure Web Service, Azure App Service website running on top of Azure Stack. So this is sitting in a data center in Redmond. This could be any data center. We're going to hit refresh. And kind of that same few second delay as we wait for the pages to load up. But we'll see our same application. What's really powerful about this is your code can run in multiple places now. It doesn't necessarily just have to be in the cloud. You can run it on-prem with Azure Stack. And more importantly, as you'll see with Mark's session, this gives you the ability to target different environments. So pretty powerful stuff. So there's our app. Real quick, I'm going to take a couple of minutes and just kind of peel back the layers a little bit. We'll just go look at the steps and show off a few things as we go. And then I'll hand it back over to Mark. So if we go take a look at our pipeline, a handful of things that are pretty powerful about this. This is my build definition. And that build definition says whenever new code is committed, when I pushed code to it, you guys watched that when I said push, when that happens, that code lands here, these series of steps are going to take place. So if we go look at this build definition, there were a handful of things that occurred. You can see that, hey, it got sources. So it actually went out and pulled the copy of code that I was looking at. This happened to be a VSO repo in this case, but it could have been GitHub, Bitbucket, or some other options out there. Next thing it does, it restores some NuGet packages that we use. Think of those as libraries that you'll use in your app. And then this is where the magic happens. We run MS build. So it takes that solution file, compiles it, spits these files on out, and publishes them as an artifact. So this is the output. It went from all of my ASP.NET uncompiled code to, hey, now it's a web app that I can do stuff with. So that's the build piece. One really cool thing about this, if you look, the kind of automation to say anytime somebody pushes code here, it's one checkbox. It's this trigger status right here where you can enable that continuous integration. So all you do, turn this on, and it says anytime somebody commits new changes to that branch, run me a build. Key piece here, you're getting real-time feedback if your stuff is working or not, right? So the next piece of that, we had talked about building. We've got our source files. We'll now go take a look at this release phase. And here you can see I had some spotty successes yesterday as I was wrapping up for this, getting ready, but we've been all good since. If we go look at this release definition, super quick here, we'll just take a quick peek. Basically, I define it up front with artifacts. So the stuff out of the build phase, I'm now saying use that as we go into the release phase. Here I define those artifacts, so it's the output of that build. I've set a trigger that says, hey, continuous deployment. Anytime a build completes successfully, I want you to do the next steps that are in this pipeline. So then if we go look, I've got two environments defined. I've got my Azure Dev. I've got my Azure Stack. In this case, wrong one. I am using just FTP. We could be doing this with ARM templates. This could be a cloud service. There's a ton of options out here if we go take a peek. VSO is incredibly powerful in what it brings to the table. These are just the deploy phases, right? I could, Service Fabric. I can deploy a VM scale set. I can run Azure PowerShell, Azure CLI, all that fun stuff. If we go look at the other steps here, I probably should have called this out, but when we start thinking around build, it doesn't have to be .NET or Microsoft workloads. We love everything that you can throw at us. We can reach out to other tools. And then there's a ton of utility ones, expand archive, zip archive, stuff like that. So we can see Azure, Azure Stack, that's great. If we go back to our pipeline real quick, I'll show you the other piece. And this is what I love about it. It's so simple. We come down here and I set my pre-deployment approvers. So this is basically saying before I release to Azure Stack, what conditions must be true. And in this case, I'm saying, you know what? I've set some pre-deployment approvers. And in this case, probably not best practice for me to approve my own code, but what the hey, I set myself as the approver, and that's why I got the notification there. And then we'll see the same thing over here on Azure Stack. So just real quick, wanted to call this out, kind of bring everybody up to the same same plane. If you haven't been here before, taking a look at this stuff, it is incredibly powerful. I do think there's huge opportunities, especially in the IT pro space, to really dig in on this stuff. And think about how you can apply this in your normal day-to-day and the content that you work with. So with that, Mark, I'll hand it back over.
Thank you. I hadn't seen the demo before, but you just stole all my thunder.
Oh.
No, I'm joking.
Well, actually, one thing to call out, we do have a step-by-step guide for this, guys, AKAMS/hybrid CI/CD. We have a document out there that walks you through how to do everything you just saw me do.
Now, what is interesting, Ignite is typically like an IT pro event. Who would classify himself as an IT pro? The rest of you all dev? Pretty much. Who saw this for the first time, Visual Studio? Okay, good, half. I'm going to make it worse for you guys. But I'm going to look at it from the ops background. So feel comfortable, we're going to start easy, and we're going to end up in VS Code and Visual Studio again. But why? Why is this useful to you? I mean, the first time that I looked at Visual Studio and everything that says Visual Studio, I was like, well, that's apps, right? I'm like infrastructure, IT pro kind of guy. That's my background. So why should I care about Visual Studio? Usually when someone says apps, I'm like, that's development stuff. I don't want to know. One of the developments that we're seeing in the industry overall, not necessarily just Microsoft, is everything is moving to code. Right? We have infrastructure as code, management as code, and hopefully these are not necessarily new terms for you. But it is interesting to see that a lot of these, usually what was to be physical servers and storage and physical switches, now start to tend to be virtual and something that we can capture in code and configure in code. So half of you mentioned that you have some kind of development experience. I want to go through a certain flow which touches on a lot of terminology. And it's kind of helpful to understand that terminology because when I started working on infrastructure as code and coding in general, it threw me off. Right? I didn't have a clue what I was looking at with branches and commits and Git and what have you. It was all new to me. So what I'm trying to do is go through the 8 slides that I have in total to kind of touch on all that terminology. Then we'll use that terminology and throughout the demos I'll point back to it. So we're going to start very simple. Let's see if my machine is still on. Yes, it is. So let's start with version control system. Right, if you look at a normal folder on your machine, nothing fancy, what's different when a version control system comes in? Basically, it gives you an index file within that folder. That index file keeps track of changes within that folder. Now, the example that we're going to use in this case is Git. There are multiple version control systems. Git is the most commonly used. Git is also one that Heath just used in his repository to show that app, and we'll use that for our sample as well. Now, why is that index folder so interesting? Version control system allows you to see not only the changes in a folder, but also the changes in the file. Basically, each text change that you make is indexed. And that's what that index file does in that folder structure. So then there's something called branches. Branches is basically kind of a moment in time snapshot, if you will. So once you create a Git repository, a Git folder, it has an index file and it has a master branch. Now you can create multiple branches on top of that, which is a copy of that folder, just a copy of the index file, basically pointing at the files in the folder that will keep track of all the changes that are happening in that particular branch. And I can move between branches. Once I move to a branch, I'm going to see the world of that folder from that branch view. Any change that I make within the branch and that I save, only save within that branch. Once I flip over to another branch, I'm going to see that kind of snapshot, right? And that's where the commit comes in. And the commit is basically a change to the index file. So anything that I do in that branch, I can save files, I can add them, delete them, that's all good. But without making that commit, the index file is not aware of it. So basically we're updating the index file to understand what changes that happened within that branch. If I don't do the commit, if I don't update that file, the version control system is going to warn us when we switch those branches. Like, hey, wait a minute, there's unsaved changes here in the index file. You need to commit them first before you move over. So let's have a look what that actually looks like. 7, I'm going to so run out of time. So I got a simple folder here. I showed the hidden files within it. There's actually a .git file folder in it with a bunch of files. That's the index file. I also have Visual Studio Code open. Now Visual Studio Code has inbuilt integration with Git. So it just has the ability to read out that index folder that you see. So if I open that folder from Git or from Visual Studio, folder, that's the simple folder, there's really nothing in there, right? It's an empty folder. So if I now can create a new branch, so let's start with that. I'm going to create that and call that Ignite1. Oh, branch, Ignite1. It automatically switches to Ignite1. That branch is now selected here. Let's say I create a file. New readme dot md. So nothing fancy, just an empty file there. Let's say I now save this. I get a commit, or I get an option to commit. Basically, Git or Visual Studio Code sees the change, the save that I just did in that branch, and gives me the opportunity to commit it. So let's commit that, give it a message, commit, whatever. It's now updated the index file of this branch, right? So I could switch to a different branch if I want to. So if I create a new branch again, and I call that Ignite2, and I switch to that, and I delete the file. VS Code noticed that and says, hey, there's a change in this branch. Do you want to commit that to the index file? Yeah, I want to commit that. Let's call that delete. The message is whatever you would like. So the folder now has no files in it. And I'm in that second branch that I created, that second world of the truth. So when I switch back to that first branch, watch what happens within that folder. Ignite1. There's my file back. This is the basic principle of Git. And I do it now with a separate file, but it also does that with content within files. So we'll keep track of all the changes that you make within a file. Now, why is that useful? Well, if you're working on an ARM template or infrastructure as code or an application or what have you, you can keep versioning of all the change that you're making. So if you screw up, and I do that all the time, you have a way to backtrack, to undo your changes. And that's what version control system gives you. Okay. Oops. Now let's say this was my local machine. Actually, it scared me to death this morning. It's a slide. but I forgot, I put it in a deck, so I was like, oh, my machine. But let's say this was your local machine, and you encountered this issue. All your data is gone. You can have all the version control that you want, but your data is on your local machine, so it's gone. So that's where the online version of version control systems comes in. And probably you heard of GitHub, which is the online version, the web-based version of Git. But there's multiple versions of that, actually. Visual Studio Code, or Visual Studio Team Services, so VSTS, the online version of TFS, provides that same capability. So let's have a quick look at that. 15 minutes, yeah, we should be able to do so. What does that do? So I have a URL. Could be GitHub, could be Visual Studio, whatever. It's a repository online which stores my files. It has the same capability. It has branching capabilities. It keeps tracks of versioning of files that I'm doing. I can clone that data locally, which is nothing else than a copy. Now, once I make changes to it, and I'm saving that locally, it's still only locally. I'm not sure if you ever see, I should have put it in the slides. There's an image on a fire, above the fire extinguisher, that if, in case of fire, commit and push. Because otherwise, your data is gone, right? There's no use in only committing it, because that's still local. You have to push it. So that makes it available online, in the online version. Now, this is all good. I mean, we're going to skip this demo. But let's say Heath here also works on that same project that I'm working on. And he's changing the same file. And he's pushing the same file. Well, this is going to be a problem. And let's say someone else who's less experienced than Heath also works on that file, and he accidentally deletes the whole thing. And he sends a push. All data is gone. That's great. I mean, we have version control, so we can go back, but we can also prevent it. And the way that we prevent it is by setting policies. Right? You can basically set that branch to read-only. Or let's say this is a GitHub repository where you say, well, it's not in my account. I don't even have access to it. I can read from it, but I cannot write to it. That's where you ask the author, the owner, if he's willing to accept the code changes that you have for him. And we call that a pull request. So instead of me pushing the data into that repository, I'm going to ask, hey, can you verify this code? Is this a valuable addition to your code? And can you merge it? That's a bunch of terms that you now maybe better kind of understand. So a pull request is basically asking for merging that data into that online version. You see that all the time on GitHub, right? There's a pull request, there's a merge. That's basically what it is. Just evaluate the changes that I did and merge that into that master branch or whatever branch they have online. One very important and distinct thing I want to highlight here, and a lot of folks don't do this, if you make a clone of a repo that's online, and you want to make a change to it, start by creating a new branch locally. The reason why is that if you have created a pull request and you have not created a branch locally, each change that you're going to do locally, that you're going to commit, is going to be part of that pull request. So if you start to work on some other project or another feature within that same local clone, and you make a commit, it's going to end up as part of that pull request that you see online. So first, always start with creating a branch, make your changes there, do the pull request. If you have another pull request coming up, create a new branch. Okay? Now, fantastic, you might say. Now we have versioning control, so all my problems are solved. Let's have a look at some repository online. Who's used this repository before? Who's had great experience with it? just one hand out of the many hands that were going up before. I'll tell you why. Let's look at what I have here. So here's the Azure Quick Start repository. There's actually doing some good work. There are only 25 pull requests open now. Usually there are a lot more. But if you look at the amount of issues, there's 350. So this is an actively used repository which has over 500 solution templates in it. Now what happens if you use that VCS pipeline, you did all the version control, you started authoring your own templates, you created all the artifacts, you're now done, you're happy, you create the pull request, and then we as Microsoft say, well, that's great, but hey, let's just pull one. Here's that's 13 items open. There's a list of, and I feel sorry for the guy that created the pull request, but there's a list of items with best practices. Let's see if there's another that actually has that expanded. Maybe this one. Yeah, perfect. So the pull request response is a list with best practices. There's a bunch of best practices on this repository which basically say, go do this, go do that, go do that. Once you've authored your template, we start to push back, which basically say, hey, go update this value. You're using a parameter for your API version. That should be a literal value. There's a bunch of best practices that will prevent the pull request from being merged. So you need to kind of obey certain rules, which is just for this repository, right? But there's no generic guideline that we have. We have rules for this repository, but for your organization, that might be different. You might say, well, I don't care whether that API version is literal or not. Or you might say, I have a separate set of values that I find important. So why have that evaluation all the way at the end? That's kind of what we're looking for now. Let's go back. Okay, so we're back. We just did that pull request. How does that line into that build and release that Heath just showed us earlier, right? So let's say I did that pull request. It now awaits approval from the person that owns that repository. So once, obviously you can do a manual review, what a lot of folks now are doing, so they're literally scrolling through that template. Hey, here's something that you should change, here's something that you should change. Or you can do some kind of automation, but that's hard. We don't really have proper automation for this, right? How do you evaluate a template? You can deploy it. If it works, then great. But what if the deployment takes 3 hours? You're gonna wait for that each and every time? Each time that you do a change, you're gonna wait 3 hours again? That's kind of the challenge that we're facing here. So if you look at build, what does that? Let's say those bunch of tests that he showed, it runs and it evaluates the change that you just pushed out. And it says, it doesn't comply with the changes that you just did or with the policies that were just set. Okay, I'm gonna make the changes that you require. So what's gonna happen next? The build's gonna run again. It's gonna fail again because there are some other changes that you didn't do yet. You're gonna make those changes too. Oh, now I'm compliant with all the changes that are required. Then the next step kicks in, and that's that build process. Before that next steps kick in, I made some fancy automation in the slides. You saw those 3 changes merging into the repo. Because I now adhere to the requirements that that repository has, my changes are automatically accepted. Now you can do that manually if you want to, but there's no need. This is the benefit of a CI/CD pipeline. You can automate that. Now, and here comes a real challenge, 40 minutes. How do you automate that? Because we don't have anything for it. This is the goal. Today, if you create a template or an artifact or a marketplace item or for Azure Stack, a managed app, it doesn't matter. you start working and authoring on your own machine, right? You create a new template, there's a bunch of resources, you might get an existing template, you go change that, and then how do you test? Probably, at least that's what I started with, I deploy, right? And it fails. Oh, I need to change this. And deploy again. Oh, that fails too. I need to fix that. So that's not really a healthy experience, right? It usually takes a long time, and it's frustrating as well. And eventually, when you say, oh, now it finally deploys, let's do that pull request to the Azure Quick Start template repo. Now some nagging Microsoft guys start to push back on it because I'm not using a literal API version. Couldn't they just have told me that before? I mean, then I would have done it earlier. The more time progresses in your authoring procedure, the more changes you're making to the template, the more time consuming it is, and the more tests that we throw at it. We want to revert that process. How do we go from this slide to this? How do we get those changes as early, or those tests as early as possible, without me reading through a zillion pieces of documentation to understand what the best practices are? I want to have that automated. Now we get to the experimental stuff. That's what I'm trying to achieve. I'm not there yet, so, but I didn't want to hold back, right? So I want to show you what path we're on and trying to see if that's valuable for you or not. So what we're currently working on is a module, which is a PowerShell module. And we're doing that in PowerShell because the majority of the folks that will be working with this are the IT pros. They're the ones in charge of that infrastructure as code and that management as code. It's the developers that will focus on the application itself. Who's familiar with test suites? And not necessarily this one, but just overall. 2, 3 hands. There's a bunch of them. The goal of a test suite is to do test-driven deployment. Basically, you write the test first before you start coding. And then you define in the test what the outcome is of the code that you're writing. So it's the reverse world. And your code is only going to be successful if it complies with the outcome of the test. So the code that you will have in your master branch is always going to be successful because it won't get merged before it passes the test. Now you might think to yourself, like, yeah, but it's double the work because now I get to write the test first and then I have to write the code. Well, it is, but it's going to save you a lot of time in the long run. It's an investment like anything else. But if you look in the long run, I mean, how many redos and redeployments, what have you done on those ARM templates? That's time consuming. And hopefully we can take some time away by coming up with solutions like this to write this for you. Who's familiar with Pester? More hands, good. IT Pro audience. Pester is a test suite for PowerShell. ARM is not PowerShell. ARM is JSON. Or you use JSON language for ARM templates and related artifacts. And there's a whole bunch of them. So why Pester? Well, Pester is basically plain PowerShell. There's a bunch of terminology or terms that you have to be aware of, I think 4 in total. But other than that, it's just a plain PowerShell script that you're running. And the test that you're about to see is not necessarily about the tests themselves. It's extensible, so you can add your own tests to it. It's just plain PowerShell tests. It's much more about the framework that you can reuse, whether that you're using that locally in some pipeline, whether that's VSTS or Jenkins or what have you, or that you want to integrate that with VS Code or Visual Studio or Git. I want to make that as modular as possible. So if we look at what this testing does, it allows you to do unit testing and integration testing. Now, what's unit testing, integration testing? Unit testing basically taking a single file and evaluating that. Integration testing could be, well, I got a parameter file and I got an ARM template. I want to validate whether the parameters match the input in the ARM template. Or I want to verify the output of my create UI definition with the values that are in the ARM template. I think the biggest challenge that I was facing, how the heck do I identify what file I'm dealing with? Because we have guidance, which is not consistent. We have guidance for managed apps. We have guidance for Azure Marketplace items. We have guidance for Azure Stack Marketplace items. And we have guidance for Quick Start templates. They're all the same artifacts. It's all different guidance. So how do we help you there? Besides the fact that we need to solve this, how do we help you? And that's something that we can do with a policy. Right? I've tried to look at extensions. Is it a JSON file? I tried to look at the content. Has it a certain schema? But it all depends on what you put in there. So if you put in the wrong URL for the schema, I don't know what file I'm dealing with. So let's have a look. 7. Okay. First of all, for the unit testing, you can do that all locally. You need nothing in Azure or Azure Stack or whatsoever. It's a local script that's executed because I'm evaluating something inside a single file. Now, once I start to do integration testing, this becomes more complicated because Azure Resource Manager in both Azure and Azure Stack allows you to expand an ARM template. We could do a test deployment. Who's familiar with a test deployment? 2, 3, 4. So a test deployment basically says, hey, ARM, here's a template. Here's a bunch of parameters. Test whether this deployment will be successful. Now, it's not going to be the same test as doing the actual deployments. There are certain tests that the resource providers won't do in that particular test deployment case, but it does expand the template. So there's a bunch of template functions, nested templates, there's variables. All those values will be expanded to its end state and flattened. So if you have copy in your template, you will see the expanded version of those resources. That's what you can get back from a test deployment. Now that allows us to compare something. We now have the original template and we have the expanded version. And we can compare those. But to do that test deployment, I need to have access to Azure Resource Manager. I need to sign in. And that's what we do with a, well, you can do a login Azure RM account, whether that's Azure or Azure Stack, it doesn't matter. But to automate that, we use a service principal. So we need to set that up, that service principal, that's one. Then we need a couple of endpoints, because we need to tell that automation engine where should I communicate with? Where is ARM? Is that Azure Stack? Is that Azure China? Whatever. It doesn't really matter. We need to know where to communicate with. Another interesting challenge is when you say, well, I'm on Azure Stack or I have artifacts that I don't want to have in the public domain because I spend a lot of time on creating those artifacts. There's IP for me in there. I don't want to share that on GitHub. Well, how do we make that available for Azure Resource Manager? Because at deployment time, it's going to reach out to all those resources. And it has to be accessible for Azure Resource Manager. So say you got Azure Stack sitting on some submarine somewhere. It's great that you got GitHub and you have stored your artifacts there, but it's never going to be able to retrieve it. So how do you deal with that? And that's where we, at least that's the approach that I took. Since we have access to that Azure or Azure Stack environment anyway, why not provision a blob account and upload those artifacts there? Just for the test. We can leave them there if we want to, but basically clean them up afterwards. We have one environment URL, which is the artifact location. That's a parameter that we use today for templates as well, which has a default value. And we can override that, basically setting the default value to temporary location of that blob, and that allows ARM to retrieve all those artifacts sitting there. Nested templates, scripts, what have you. right? And you can hold that all in the confinements of your own Azure Stack environment, whether that has access or not. So there's no dependency on any GitHub or any public repository here. Okay. So we need SPN. We need a storage account with a blob in there, or the blob's going to create automatically, but we need a storage account, and we need a resource group to do the test deployment to. So that's 2 resource group and 1 storage account in there. So there's 1 script which provisions that all for you. So that's 2 storage accounts, SPN, it sets RBAC on the resource groups, and it sets RBAC on the storage account. Just around the amount of permissions that you need to perform all those tests. We need to store that data somewhere. Because if I create that through PowerShell, and I want to automate that over and over and over again, we might, of course, retrieve all that data, generate all those storage accounts, regenerate it. It's all idempotent. You can if you want to, but it's very time consuming. So what I've done is come up with a construct of a JSON file which contains a couple of elements. Let's go have a look at that. I'll start with importing the module. Now that module is not done yet. Fortunately, I would have liked to show more. But what it does, it provisions a bunch of functions which we can use throughout that testing procedure. Let's do that. So it's important, and once it's imported, you can have a look at the commands that are there. So there's disable ARM test kidhook, there's enable it, there's a test environment, policy, invoke ARM test. There's nothing which says invoke pester. It's a whole bunch of wrappers basically, which makes the heavy lifting easy. So I did the heavy lifting for you. The first thing that we're going to do, and let's see if it's working for me. I see a whole lot of red this morning, so looking forward to that again. I think there's a pop-up after here. Yep. So I'm going to sign into my environment. That might not work. To create those 2 storage accounts, or to the 2 resource groups, to create the storage account, to create the SPN, the application, and set RBAC on all those items. And this works both on Azure and Azure Stack. It doesn't really matter. Good. Let's get back to VS Code. Wait for the outcome. So nothing fancy here, right? I imported a module and I signed into Azure in this case. Next one is I'm going to run that script to do all that heavy lifting for me, and then I'm going to capture that in a variable. So it's going to import a bunch of commandlets. Since I want it to be consistent for Azure Stack as well, I'm using the profile. So this will work on both on Azure and Azure Stack. As you can see, it's generating some unique name based on my input and the subscription ID. Then it's creating an application ID. It's creating 2 resource groups. It's creating a new storage account. And then it's going to wait for some while for the application ID to be available. Usually take a couple of seconds, so I have a sleep for 10 seconds, I believe. Then it's going to create the SPN and set RBAC on that SPN. That's the 10 seconds that I referred to. Once I have that, you'll see that in the output of this function, I have a whole bunch of environment details. Basically, the resources that I create, the endpoints, and it has a password. And that's a password for the application ID that I need to sign in. Now, the only thing that I won't use throughout this is that password. You'll have to store it somewhere. You'll store that in your pipeline, you store that locally, but that's something that you'll only get once. Now you can rerun this same script. It's going to generate a new password for you. So it's idempotent. You can run it against the same environment, same values. If you use the same environment, other values, actually that's what I'm doing, it's going to create a new SPN, new application, new resource groups, new storage account, besides the one that you have. So you have flexibility there. So I got that now. Let's look at the output, that variable. Go bring out your camera, because that has the key as well, so you can sign into my subscription if you want to. But you see that it has a password. Charles is going to make a photo. Then there's a bunch of ARM test resources. So that's the service principal. There's endpoints, there's artifacts, and there's deployment. Now, I'm not going to go in the depth of what I've done with custom policies, because you can override the main policy, which is going to apply to all the deployments that you're doing, with custom policies for each deployment that you have. Because you might say, well, it's great that I do an integration test for all of my solution templates that I have, which matches the parameters for the parameter file and the ARM template, but for that particular deployment, I want to match what I have in my resource group deployed compared to what's in the template. What are the changes? Not sure if you're familiar with Terraform Plan, but basically it's a similar approach, right? You see the diff between what's in your template and what's deployed. You can do that with that custom policy. So each solution template can have its own custom policy with its own integration testing and its own unit testing. I just want to keep it simple for now. It's complicated enough. So once we have that value, I create a new policy. Now the policy is that JSON file that I referred to earlier, but also the templates for the test files, so the pester test files. So let's run that. See where I'm going to drop that in cgit ignite. Let's browse to that folder. Cgit ignite. There's a new folder you can see from the time it's actually just created, folder called test. There's a bunch of files in there. There's a file called armtestpolicy.json. There's a bunch of PowerShell files, PS1 files. Some of them are unit, and there's one integration. So if I look at the policy file first, see what the content is. Let's get rid of this. You'll see that the same content that we just retrieved from that environment is put in that policy file. Right? It's the same endpoints, but now we have it stored on disk, if you will. That's the reason why the password is not in there. This has no privacy data stored anywhere here. Right? You need to have that password to be able to do anything with this. You already have that on your photo, so you can use it. But there's more data on it. There's unit and integration. There's 2 entries, and each entry has a bunch of files and some metadata. Now, if we look at unit, obviously those entries will be used for unit testing. It basically describes the files which are allowed in your solution template. You can change it to anything that you want. Anything that deviates is going to throw an error while we run the tests. So this enforces naming convention. This enforces that your files are stored in a certain way. Still, with the policy, you can define whichever way you want to, but any solution template has to adhere to that policy. So now you can standardize, and with standardization, you can do automation, right? Without that, it's going to be a mess. So that's the files which are allowed. Then there's integration testing, and that's a bunch of files that are required. So I will only do those integration testing if all the files which are in this policy are present on disk. If they're not, I'm not going to execute any test. I'm going to throw an error because it's missing those files. Make sense? Then each file can have one or multiple tests assigned to it. I know this is a lot to grasp, but it's a hard topic to solve. Each test is going to be invoked when it complies with that policy. And the test file is the one that we also created. in that same folder. So if I change a file called main-template.json, it triggers the test. It's going to verify, hey, is there a test specified? Is it a valid file in my policy? Then yes, I'm going to execute that test. Now there's a readme.md, it has nothing specified. So I'm not going to invoke a test on it either. But you have full flexibility. Now the benefit is here that we define a predefined set. So you at least can, if you use the default, then you adhere to what everyone's using. But if you want to deviate, you can. Right? So that's great, but am I just then going to start an invoke test on all of that files? So let's say I got them all. It's going to do 1, 2, 3, 4, 5, 7 invoke vector tests. And what if I have 500 solution templates and I want to test those? Is it 7 times 500? That's a lot of vector tests that I'm running. Actually, the script is more intelligent than that. It will filter out based on the mapping. Hey, each deployment template.ps1, which files need to be tested. Then the array of those files will be parsed to that single test, and it will iterate through those files. How are we doing on time? Okay. So if you look at a test, let's just open one deployment template. It's just plain PowerShell, right? It has a parent block. It got a test equals 1 minus 1. Test should be null or empty. There's a bunch of nouns that you might throw you off, like describe, context, it, and should. Those are typically test case or test suite nouns. But other than that, I can just add PowerShell to this. And it will inject each file into a test, and it will repeat that for each file. Now let's look at one that has already some tests in there. And go to another folder, get demo. Now I made it a bit harder because my solution templates are not in the root folder here, it's in a nested folder. So I need to specify where that nested folder is, otherwise I don't know. Then there's a folder called test as well. It looks identical. It has a policy as well. Looks also identical. And if I were to change the main template.json, it's going to execute this test. So let's have a look at that test. So that's the deployment template.ps1. Deployment template.ps1. Now this has a bit more data in it. I didn't expand the full values I see. VS Code's reminding me of that. But you now see that there's a bunch of tests in here. But it's extensible. You can add any test that you want to, right? The only thing that I'm passing down is a PowerShell object. And that PowerShell object represents that template, whether it's an ARM template or something else. So we'll look at the test that it's doing. It's going to verify whether it's valid JSON. It's going to verify based on some regex values whether the parent folder uses camel case, whether the file format is in camel case. I'm going to verify whether all the main elements are there. So schema, parameters, version, resources, output, and in the right order. Schema URI. Am I using HTTPS? Am I using the latest version? These are all very basic steps, very basic tests, but you should be or you will be surprised by the amount of pushback that we do on the Quick Start repo, which are basically these tests. Right? These are simple things that we can capture very early. Now we can get way more complicated here if we want to, but I just wanted to get started simple. Right? So there's a here. Every resource must have a literal API version. That's the one that we push back for on the repo. Right? You just saw me pull that up for the Quick Start repo. There were like 8 or 9 items that needed to change because it didn't have a literal API version. Okay, so let's go back to the script that I was doing. So I just created that policy. Now, the policy is still in the variable, so in policy, but I'm actually going to get that other one that I already have with a bunch of tests in there. So that might throw some more interesting data. So let's get that policy. But it's a similar policy, right? So if I look at the content of that, see the output is basically just an object of that PowerShell that we just looked at. I add 2 values to it, so that's the path of the test file as well as the file name itself. But other than that, it's the content of the JSON file. So what can I do with that? I'm going to now start that invoke pester test. And I'm going to do that for one file. I just did that. And that's that C, git, demo, solutions, Mesos, main template.json. Single file that I'm going to run that test against. I don't have to make any change. Right? The benefit of the script that it allows you to do it on change files, but you can also run this against a full solution template folder, against 500 folders if you want to, for all I care. So let's run that and see what the output looks like. So it gives me a whole bunch of data. I did for both logging on, so it gives me more input. And it basically says, hey, I'm going to verify all the files that you just thrown at me, which is one, could be multiple. And what kind of test am I going to invoke on that? There's a bunch of filters that I can set where I just want to use unit testing or integration testing as well. And it's going to verify that against that policy that I have. So if the file is within policy, which it is, then it's going to look at that policy and say, which test do you want me to invoke? And that's the test that is in that policy. So it passes down that file, and it executes that policy with the file in it, or the pester test with the file in it. And you can see that all the tests that I have successfully succeed, which is obvious because I made sure up front before I had the demo that it works. But if we were to make a file change, it will throw an error. Now, why is that useful in that CI/CD pipeline? Let's go look at that and make a change actually in the file itself. So let's go to Solutions, Mesos, and open the file here. And we know that I was checking for schema URI and whether that was using HTTPS in the latest version. So if I delete the S here and make it just HTTP, save the file, and now before I do the commit, this is a local clone of the copy that I had in my online version. And just as Heath showed, I enabled a build process with those tests, basically with this test, but then in that build process. So let's have a look at that. Here's the same code. This is my online version. So let's go to build. And before I commit and push, I'm actually going to show you what that looks like. I have way more red than you, Heath. And it's just a bunch of PowerShell scripts, nothing fancy. Right? You can see this as a trigger for some automation that you're doing. That's where kind of ops meets dev. So the first thing I'm doing, I'm installing Pester. So this runs on some agent, right? There's a VM running somewhere which I perform these tests on. That could be on Azure Stack. I'm using just a freebie one from VSTS right now, but it could be anywhere. It could be any VM that you define. Then once Pester is installed, I'm going to get the changes that are in the push or in the pull request, depending how I configure this. Because I don't want to execute this on all my code, because if I had 500 templates in there, it's going to do 500 times the test. I don't want that. I just want the files which were changed. Once it's done, it's going to execute the log. So it's only going to verify, hey, is the file that is changed valid? Does it comply with that policy? If not, I'm going to throw an error. The pipeline's going to stop. So it can't continue before I fix that issue. Once that issue is fixed, It's going to invoke the test. So now I have a valid file, complies with the policy. It's going to execute that test. Probably it's going to fail because I just had a value which was not compliant with my policy. Same thing, and I did not highlight it here because of the dependencies on Azure that I have. But it's going to do that for the integration test. So it's going to verify, are all the files that I need present on disk, on that agent, with the version that I just updated for the change that I made. If they are, I'm going to proceed. If they're not, I'm going to throw an error. My build process is going to stop. Once that's successful, I'm going to do the integration test. I haven't deployed anything yet. Right? I'm not using any Azure cycles. This is all offline testing. The only thing that I'm doing is connecting to Azure, get me the expanded version, and I'm going to evaluate based on that. No deployment yet. Right? The deployment comes in at the release. Right? Once you go through this phase, say, yes, now my template complies with all the policies that I have in place, all the tests are valid. Now I'm going to do a release, and I'm going to make sure that the template deploys successfully. Once that is done, I'm going to take that artifact, and I'm going to push it to my Azure Stack Marketplace. Or I'm going to upload it to my environment in Azure. I'm going to deploy it to my production environment, what have you. Right? But now you have a whole bunch of tests for your infrastructure as code colliding with your tests that you have for your application as code. So let's just see what happens if I kick out that change. The other one, I saved it, I'm going to commit it, HTTP, and push it. Go back to my demo environment, say build. Let's open that latest one. Should be starting now. Here it is. So it's in progress. Automatically starts. It's just automation. There's a bunch of things it's going to do. It's going to pull down all the data from my repo. Right? That could be on Azure Stack. So if I'm using VSTS in this case, I need to have access to it. So I need to have outbound internet connectivity. If I'm using Jenkins, which I install in my home environment, it's going to reach out to that. Right? Whatever pipeline you use, it's fine by me. Once that is done, it's going to install Pester. Now, this is a hosted agent. I have no admin access on this thing. So everything happens in the scope of the current user. 2 minutes? Well, we should be good. I'm almost done. So it's getting the sources, as you can see, retrieving all the objects from my repository. That's installing Pester in the current user. It's getting the change files. And it's only going to start off that script with the change file. Now, it should throw an error. There it is. Because I specified HTTP instead of HTTPS. So it does the same test that I do locally. But the benefit here is it doesn't continue my build process. Right? So all the automation is basically preventing you from adding any code you don't want in there. Last thing I want to show you, because we talked about how, and I'll make it very short, how do I get this as early as possible, is that there's another function. Let's open this one, which is called enable Git hooks. Let's run that. So I just enabled the hook for this Git repository, which triggers the same script again. So when I now go back to my main template and I up the version to 1.1, I still have that error of the HTTP and not HTTPS value. So if I now do a save, and I go look at the output, and I do a commit. Oh, commit. It's running the test directly in my VS Code. And I see the same value there. How close can you get to authoring and testing your template at the same time? I mean, it's not that you have to wait all the way at the end till you push that up to some pull request to your repo somewhere. While you're creating, it's running the test for you. It's not blocking you from committing. That's what the CI/CD pipeline does for you, right? But you get the notification immediately. I did promise some Azure Stack Marketplace because that was the title of the session, and therefore I'd like to introduce Carsten.
Hi, I'm Carsten from Germany. I'm a Microsoft Cloud and Data Center Management MVP, and I'm also a Regional Director, Microsoft Regional Director for Germany. And I have to earn some money, so I own a company called Rachfal IT Solutions, and we were so fortunate starting in 2017 to help Microsoft to validate Azure Stack with the help of Mark. We did some things there, and there is one thing in Azure Stack I'm very excited about. There are more, but in the context of this presentation, it's a marketplace syndication. And we saw all the nice ARM templates, the stuff you can do there, the testing and all of it. And if you have an Azure marketplace item, there is ARM included. So if you develop something like that, there is ARM there, and of course you have a whole solution. And I want to show you how you can get a complete solution from the Azure marketplace down to your Azure Stack. And for me that's very great because I was a developer years ago, but I can't do that stuff anymore. So I'm happy that I can get complete solutions. So let's switch here to the demo machine, and I'm on an Azure Stack in Redmond, right?
Yep.
So we are here. We have not much time, so let me see where the marketplace is. Here it's the marketplace management. I had it here too. Thank you very much. And we see now some solutions that are already downloaded from the Azure Marketplace to the Azure Stack. And if I want more, I add from Azure. So I click Add from Azure. I will hopefully get a catalog here. That's some problem. There it is. Fantastic. And you see prepared solutions here in the Azure Marketplace, and there are quite a lot. So I can scroll down here. We have images that you can redeploy, like Windows Server, Ubuntu, various Linux images, but we have also like WordPress, Node.js, a lot of stuff you maybe want to redeploy in your Azure Stack. So let's just choose one of those. No, let's take a Debian image. I click on the Debian 8 Jesse. I get a little bit to read if I comply with the licensing and so on, and if I want that, I click download. Yes, downloading product started. So if I close this, so now after, I would say, some hours, because it's a huge image, I think it was 30 gigabytes or so, it will be now downloaded from the Azure Data Center to my Azure Stack, and I can use it for my tenants. So you have a ready-to-use solution there, and this is something I'm really excited about. So that was my demo. It was a short one. We can't do more because we have only 1 minute left.
Yeah, thanks, Carsten. So it was a tough topic. I do thank you for writing it out. There's still some rough edges to it. I'll try to polish a bit more to make it as easy as possible. but still keeping it as flexible as possible so you can use it in your local environment, you can use it in your CI/CD pipeline, whatever solution you're using, that's fine. And feedback, and that's really what I'm looking for. Thank you for your time. Enjoy the rest of the conference, and don't forget to vote for the session. Thanks, guys.